Let's talk about piping. So we are right here in piping and fitting section, and let's cover piping. So what's the overall description? Well, probably you know that they are used to transport fluids. You cannot do it alone. You require some fixed material that move the fluids. Typically they will be done by steel, but we're going to cover more materials. They have several sizing, and the important part right here is that they will have a dropping pressure. So we need pumps in order to counterbalance this dropping pressure. We got plenty of transport, either isothermal flow, adiabatic, and so on. So general, we got several sizes and schedule. Right here we got schedule 40 and schedule 80, which are the most common ones. As you can see, this is a little bit thinner, this is a little bit thicker. So what do the schedule means? Essentially is the thickness of the wall. So 40 is this thickness, the 80 schedule is of course twice. The inside diameter typically is the same for both pipes, but of course the external diameter will not be the same. So it's important, especially if you're going to do some calculations on heat transfer, that of course you know that heat will be harder to cross the 80 scheduled size than the 40 scheduled size. Now let me review this right here. Pipe dimensions: 1/2 inch, 3/4, 1 inch, 2 inch, and so on. Go back. Okay, perfect. Now, what type of materials do we have? Okay, we already understand what are pipes. They are typically long. So the most common one will be steel, typically used in the chemical industry. But we also have copper ones. Those are used for natural gas, maybe in home applications or more specific applications. This is very expensive compared to traditional piping. Also, we got plastics. If the materials allows it, we can use PVC or maybe even other types of plastics, and ceramics. We got ceramics right here. Ceramics are of interest. Maybe you remember there are even some clay or of course more advanced ceramic materials. So the importance on maintenance, well, they can break depending on the pressure they operate, also if they get rust and so on. Talking about rusting, well, this talks about the outside fluid. If you have a pipe and you have it exposed to the air or to water, maybe ocean water or river water, lake water, and so on, they will get rusted because they have access to oxidation or corrosive materials, mostly oxygen. They can bend depending on the charge load, maybe even because they are not well designed, and leakage, they will leak. So one important part right here is that they will fall depending on the material. Let's say they are very viscous, high density materials. If you do not apply heat, then, or maybe let's say if you decrease the temperature, they will start let's say falling the tube or pipeline. As you can see, if these were solid, then you have decreased almost by half the flow rate, and the area decreases, the cross-sectional area decreases by half, therefore the velocity will increase drastically. And some more photos on piping. Now, many times I see students that tell me that this is a pipe. Well, actually this is the covering or insulation material of a pipe that goes inside. Of course, this is much more smaller. Let's say that this is a 10-inch size, maybe inside there is a 2-inch pipe and so on. And all this is covered by insulating material, so we do not lose. Let's say we have 120 Celsius degree right here. You don't want to lose it all to the atmosphere. Let's say you don't want to, if you let it alone, it will go maybe up to 30 Celsius. But if you have insulating material, maybe it goes from 120 to 110, and there is not that much loss. If you need the temperature for further operations, then you will not need a heat exchanger and so on. You have different sizes, of course, and also very important to consider that sometimes they are ducts. What are ducts? Essentially air flows through them. More on piping, system of pipings right here. Many times you might think these are not pipings, but they are. So here is an example of one piping. This might be utility, maybe even water, atmospheric water, one pressure, and maybe just for heat transfer operation and so on. Maybe you have a polymer here inside, maybe you have a mixture and so on. Several systems on piping. They can go either to in the bottom or top of the industry. They will be labeled. For instance, we have water supply right here. We go with, well, this is not that clear, but you will have maybe humidity levels on here, maybe dry air, maybe clean air. You will have also nitrogen if you're using argon and so on. You will have all the labels.